Hey guys and girls, welcome back to another beautiful video on this beautiful channel on this beautiful day. How are y'all doing? I hope you're doing great as always. Please check out the description box for all the nice links. Also drop a like, subscribe if you like the content. Check out the top right eye as well for even more nice links. All right, so today is a special day and we're going to talk about a special topic that we haven't really covered. I assumed we had covered this while making games, but not all of you are making games. Not all of you do code watching this video. So I want to give you an explanation of what happens in the background of a game, what a game is. So the next time you're playing a game or you're viewing a game, you'll see, or you'll try to maybe look deeper into it. You'll understand what makes a game, what is happening in the background and why it's happening. So that's the questions I want to answer today. And hopefully you'll get an answer from this. If you don't, please write in the description box, ask me a question and I'll try to answer it the best I can. Also, drop a comment of what you think a game is. What do you think is happening in the background when a game runs? What are the steps that a game goes through to actually display something on the screen? So let me know, pause the video, just let me know, and then you can keep watching it and see what's going on. But let's get right to it. So I have a little window open here. This is just to explain to you guys later on with examples what's going on, just so you can see it for yourself with your own eyes. Very short example, very clean example. But first of all, I want to talk a little bit on this topic. So firstly, an application like this editor here, it's called Visual Studio, or a video editor, or anything that you use, VLC, maybe you're using that, Chrome, you probably use Firefox, even Internet Explorer, guys, even that is an application. And an application doesn't just start and end, does it? Because the way the computer interprets commands while you're coding. So this is just an empty application, but basically just very basic to those of you who don't code, a computer receives instructions in the form of these files, and it's often in machine code. So it's binary and it's very fast for the computer to read, but it's often from left to right, top to bottom. So there is an end to every application. Of course, if I close this application, it says close here, it will end the application, right? But while I'm running it, I don't want it to just do something and end really quickly, right? That is something that we solve using a loop. Now, a loop is very important when it comes to games because you don't want to just open your game and have it end after just running through everything, right? You want to be in the game. You want to have it open for as long as you want. So that's basically what it is. Every application has a loop. And I'm just going to write that here for you guys. So it's a loop. And I'll show you as well what happens there. But just remember that a loop is very important. And then any application can have a loop, but that doesn't make it a game, right? It just makes it an application. That's all it is. But what a game is, basically, a game, just to define that word, it's something that entertains us, right? It's something entertaining, something we can play, something we can have fun with. Of course, you can have fun in here coding, but it's not a game really, is it? It's not something that you can give input to and get some kind of entertainment from, just, mindless entertainment. This actually creates something, not to be demeaning to games. That's how it is. So that's how I differ a game from an application. It's entertaining in a way that is kind of mindless and it's just for fun. It has some kind of probably graphical, visual appeal to it and something happening. You're doing something, you're getting a graphical representation of the world, some kind of world that you're playing in. So that's just a definition. Now, what is happening in the background? So they're just very, very basic. Let me tell you guys, remember this beautiful loop we just talked about? Well, there's a loop and everything happens in that loop. 3D and 2D games alike have a loop, have a main game loop, it's called, and where everything happens. Now, but the steps inside it is what's fun and entertaining and basically what gives you the game. A loop itself is just a loop. So in the game, you have a player, you have an entity, you have enemies, you have bullets flying about, you have crazy explosions, you have all kinds of cool stuff happening, boom, boom, boom. But they're always divided up into two sections, two things. There's logic, and then there's the visual representation of that logic. Okay, so logic, and then comes the visual representation of the logic. Always separated, because the logic is often just positions, it is velocities, the physics, the points, the math, all kinds of stuff that is just number crunching, all that stuff. Everything that isn't visual is logic, okay? The visual representation of that logic places different visual objects that you code, spheres, rectangles, textures, sprites, everything that is visual is placed using the logic onto the screen, onto the render target, onto the visual canvas, if you will, showing you what's going on. Without that, all you have is numbers. But without the numbers, all you have is just randomly placed visual objects. So these two really go together hand in hand, just like a beautiful marriage. You update the logic and you get a visual representation. So the functions we usually use in game development, and this might be basic for us 2D developers or even 3D developers that aren't working on AAA titles in an engine or something like that. But basically, basic game engine logic is basically you have a update function, and it's often called an update. It updates the logic, okay? And you have logic up here, so you understand. And then you always have a render or a draw function. Just like I said, these are separated, and these are both contained within a loop. And the loop has an end condition. And that end condition is often something like pressing the close X button, or something coming from inside, like closing the main menu might trigger an exit, all that stuff. So that basically closing the window usually ends up ending the loop and then returning out of the entire application. And this might seem crazy to you, like voodoo magic and all that stuff, but it's really not, guys. It's really not. And I'll show you an example. So if I have my main application, you don't need to know how to code, by the way. If you want to follow through, or you want to follow me in this example and you know how to code, you're going to have to link SFML and all that stuff. If you want to do that, I have SFML tutorials on my channel. SFML is a 2D graphics library, which we're going to use for the render visual representation part, and also some of the logic part. It has stuff for both. But you'll see how that works. So if you want to follow through, you're going to have to link this by yourself, or download one of my projects from GitHub, which already has everything linked. It's not too hard, guys. You can go to their homepage, sfml.com, and you'll see a bunch of tutorials on how to do stuff. Let's start. So I have my main application here. This is a comment in programming, so don't worry. This isn't going to trigger anything. It's not code. It's just like us writing to ourselves. This is not going to be a tutorial on C++ either, by the way. So let me just write cout hello world. So this is a way to write out in C++ to the screen, just simple, but this is not contained within a loop. So what's going to happen when I run this? Obviously, if you guess right now, it's just going to print that out to us, and it's going to end the application. And you're probably thinking, what? It's not ended, your window's still open. Well, that doesn't mean the application didn't end. I can't do anything else in this application. It says here as well, pretty much in layman terms, that it ended. You can press any button to close the window. And it's a very bad application because it doesn't do anything. I can write my name here, whatever. If I put this in a loop, now there's a loop called a while loop, and I'll make it infinite. You coders out there probably already know what a game is. So why are you watching this, by the way? Thanks for the support watching this anyway. But you guys who don't know what this is, basically in English, this is loop infinitely. That's what this is doing. Loop this infinitely. Don't reach the end of the application, which is here. Remember, it reads from top to bottom, left to right, top to bottom. So while I'm here, it will never reach the end of the application. That's what this loop does. So what this is going to be is just an infinite, beautiful, hello world spamming application. That's what it's doing. And it will keep doing this until I somehow crash or whatever. The computer crashes, whatever happens. So you don't like this. This isn't cool. Now let's add a condition to this to end the application. So very, very simply, I'm just going to create a integer value here, which I will get something into from the screen. I'll tell the user to write something. Please input a number greater than 10, for example. This is just a message to the user, so you know what's going on. Now I'm going to actually input something. Again, don't worry too much about the code here. Just see what's going on. So I'm inputting something here into this little box here, and we'll check it if the loop, we'll try to end the loop using this, okay? So if, what did I say? If it's greater than 10, to exit. To exit the program, input a number greater than 10. So we'll see. If it's less than equal to 10, we'll keep looping. As soon as it's bigger than 10, greater than 10, we'll quit the loop. That's basically what this condition here is for, to end the loop at a certain point if something is satisfied, some condition is satisfied. And that means we're going to have to do this in here as well. So we're going to keep printing hello world plus this new message for the user to input something from within the loop to exit it. So let's run this. This infinite loop, let's do 2, 3, 4, 5, 2. This could be like a game. If you find this entertaining, this is a game, right? And I think I inputted something that was like 22. So 22, it ended the application for me. Until I didn't reach that end of the loop or the condition, for the loop to end, it kept going. Now in a game example, this end condition could be something like I said, closing the window or dying or pressing the escape button or exit from within the game. Could be something like that. So let's keep the while loop here. Let's remove everything else. That's just a basic application, right? It's not really a game for you guys. What we're gonna do now is we're gonna straight up make a little mini game here for you guys. Create the window is what we're gonna do. We're gonna create a player object, which we're gonna then move. We're gonna leave that empty there. Then we're gonna define a few things. Okay, that's the steps we're gonna take, but we're not gonna do it here. I'm gonna confuse you guys even more and do it in a class here, but don't worry again too much about the code. Usually when you're making a game, you make a game class to contain all your window, player, all that stuff, so you don't have to send in those values. It's very complicated in C++, all right? You gotta send in values. It's very annoying, but let's do it like this. Ignoring the code, guys, just think about what's going on, okay? So we still have our main application here. This is our main application. I'm gonna remove all this crap that we don't need anymore. I'm gonna keep the while loop, all right? Now we made a game object here. Nothing really special, guys. Let me put that right there. Let me open that. Let me put this to the side so you can see both the windows at the same time. So we're gonna just take all this stuff and put it in our thing here. This is just coding, me coding away. Don't worry. Include game.h. Now if you coders want to follow through again, use the game class technique here and it will be great. So we don't really have anything here. We included a game. That's basically our engine, okay? This is a game engine, whatever. We're making a game engine here. Let's make a new game object, game. Nothing special. The beautiful stuff you'll see will be here. So I'm just gonna quickly create our game here. Of course, we need a window to render stuff on. So I'm going to create a render window in SFML. Very simple, just a window. Now in here, we're going to create some stuff. Let me just define that quickly. Sorry if I'm going too fast, but we're going to initialize our window. All right, and we're going to divide this up into functions. So basically a game, usually you have functions that set stuff up and then things like the update and render. So this is just a setup function. Initialize the window, basically. Just set it up for me. So I'm going to call that, create it here, and we're going to create our window. So I'm going to say create here, and I'm going to go ahead and do a size for the window here. I'm going to give a size. So it's going to be a small window, 800 by 600. I know you guys got 4K resolutions going and all that stuff, but if you want to do it, you can do it. I'm just going to do this. My super cringy title here, super swag example, straight up, okay, straight up. So let me show you what happened here. Basically just created a window with this size, with this title. That's it guys. Don't worry about it too much, but that's all that happened. I'm just gonna call that here in the constructor's call. This is all kind of stuff you don't have to think about if you're not a coder, but we just created our window. Imagine we just created a window. This is something we would do in a game. That's a step. And then we're of course gonna have a player, right? So we're gonna have void init player. We're going to initialize our player. Now, initialize basically means that we're setting up the player for use later. So I'm going to create a little section where I can do some player-specific creation stuff. Okay? I'm going to create a player as a rectangle shape player. And a rectangle shape is basically from SFML. And it's just a rectangle, which you can assign color and size to, and you can see it. You can represent it visually. And I'm going to just say that the player gets a size. Set the size of this player object to maybe SF vector 2F, don't mind this. Let's set it to 50, 50. So 50 pixels wide, 50 pixels high. Very simple. Let's give him or her a good color. Set fill color, SF color, what is visible? Green is visible. Green is nice, like the matrix, right? So once you have these two things and we call them here, you will have initialized a window, created a window, and a player by the time you create your game object in main, okay? Just for the coders out there. If you're not a coder, just think of this as creating a window and a player that we can use later. So that's step one. Now, like we talked about before, what did we have? We had two steps, right? So any game engine, any game has a logical part and a visual representation part. And we call those update and render, right? So I'm gonna create those functions now, update and void render. Two very simple functions. This is how we divide it up. And I'm going to define these for us here. So we're just sectioning off all our computation into two different functions here. Takes care of all the logic, and this takes care of representing the logic visually. If I could spell correctly, I think. Now we have our update and render function ready, but nothing is happening here. That's actually by design right now, guys, because I want to just fix this right quick. Now a condition, we need a condition for the game to end. And a condition for the game to end would be something to do with the window closing. And that's what I'm gonna do right now. I'm gonna create a little teeny weeny function here, a public function, which just gets bool is window open. Okay, very simple, very simple. Very simple. You don't have to set it to const. I'm doing const here because I like const. You don't have to think about that. But go to game, and we're gonna just check if the window is open. Now the window is internal in our engine, so to access it outside, of course, we need a little function to just push it outside so we can check if it's open or not. All I'm gonna do is I'm gonna return this window is open. That's it. I'm just checking if the window is still open. All we need to do. And now I'm gonna do a technical thing here, which is called polling for events. Very simplified. When I press the X button, nothing actually happens. You have to check for that. You have to check in your game or in this SFML if you're pressing the button or not, and then do what you want to do if that button is pressed. That's why we need to check the window for this event. That's called a poll the event. So I'm going to do that in the logic section because it's nothing visual, you know, it's just logic. So I'm going to do that here. I'm going to poll window events. Again, nothing you guys need to think about. Let me just finish coding this. Window.poll event e sf event e. So we're just catching an event from the window. If the button is pressed, that will be stored in the window as an event, and we'll just catch that. We'll check. Polling is basically just checking for something that has happened. Now, if we have found, it's like a queue as well. Every event that you press, it will be queued up here. That's why we have a while loop to go through all of those. Let's see if the e.type is sf event closed. So basically in English, this means if the event is that the close button has been pressed, what do you want to do, guys? What do you want to do? Of course, we want to do window.close. So we want to close the window as soon as we receive an event that the X button has been pressed. And this is basically it. Boom, bam, finished. Nothing more to think about. Leave that as it is, like that. And then we'll be able to actually see. Otherwise, if you press the X button, nothing's going to happen. So now what we're going to do here is we're going to check game.isWindow. Let's remove this. There we go. Okay, game.isWindow open. While the game's window is open, we're going to run the game. So this is our exit condition. As soon as this returns false, or this isn't true anymore, if the window is closed, then the while loop will terminate. The infinite loop that we have going, almost infinite loop, will be terminated and we'll reach the end of the application. So this is our heart here. This is our heart of the game. This is just initializing the game engine, and then this will be the heart of the game. Now this game isn't, like I said, it's not really entertaining in a way unless you find moving an object entertaining, but we'll see how that works out for you guys. So here we're gonna do some input for player movement, and here we're gonna render the player. To show you an example of how everything works, let's do the logic here. If SF keyboard is key pressed, SF keyboard key. So how do you move right in games? Usually it's the D button, right? This is how you check if the keyboard button D is being pressed in SFML. Of course, if it is, we want to do something. So what will we do? Well, we want to move our player. Now we already created our player here, and we want to just move it. Now, nicely enough, SFML has included a move function, which basically takes the current position of the player object, this little rectangle, and it adds whatever we write here to it. Okay, so we'll keep adding to it. As long as the D button is pressed, we'll add to that current position plus something. That's what an offset is. Let's see. What do we want to do? We want to move it by 10 to the right. Now, think of this as a coordinate system. The positive Y is downwards though, and the positive X is to the right. The negative X is to the left, and the negative Y is to the top. That's how SFML works. That's why you're going to see a few negative values here. And this is the X coordinate, and this is the Y coordinate. So we want to move 10 pixels to the right from the current position of the player. The next time this is called, we'll have a new current position and we'll add 10 to that. So we'll keep moving to the right. Hopefully you can see that. There is a set position function as well, which just sets the position to the position you give it here relative to the window. So it will stay there it won't move the player. Once you do that, we don't need all this. There we go. Now we want a way to move to the left. So I'm going to make an else if statement here. I'm just going to quickly do this. Left is -x, so -10 here. Then we're just going to copy this whole thing here. Now we're going to create the up and down. So W is usually up, S is usually down. So what was up? It was negative, right? And I'm going to put a -10 on the Y coordinate now because up and down is on the Y coordinate. And I'm going to set X to 0. So we're basically not moving the player anywhere in the X direction if we're pressing W, only in the Y direction. Same thing here. I'm going to put 0 on the X direction and +10 on the Y coordinate. Basically, here you go. This is a very simple update, logical update for the player's movement. But the player is internally moving, but there's no way to see that visually. So to show you that, let me just run this. But first of all, what I'm going to do is I'm going to create, or I'm going to call this in the while loop. So remember, our loop needs the update, game.update first, and then game.render. So all the logic will happen here, and then we'll represent that visually in the render. So we'll keep running like this, top to bottom, top to bottom, top to bottom, until the window is closed. Next step, to show you what's happening. So if I run this, obviously we're not going to have anything but a white screen because we're not telling the computer how to render or what to render or how to clear the frame or whatever, but what we have is poll events. So these 3 buttons are going to work for us. Of course, these buttons are automatically working, but the X button is special. We have assigned it to close the application, and you'll see it close the application here. But we can't see our player. That's sad, isn't it? That's sad. But trust me, it is moving in the background. You can't just see it. All the math is being crunched. It's being moved properly. We just need to see it happen. Let's render the player, okay? Let's say window.draw. We'll draw to the window our player, depending on where it is right now at that position. But of course, we want to tell the window, okay, I'm done drawing this frame. Sorry, display. The way the computer renders, or your graphics card renders, is using frames. So each frame is like one canvas, like a Bob Ross painting in that moment of time. You have to constantly clear that frame and draw a new one. And then clear it and draw a new one relative or using, the logic from the update function. So it's constantly going to be updated. You need to clear the previous frame and add a new one. Now, to do this properly, what I want to do is I want to go to my init window and I just want to set a frame rate limit. Set frame rate limit to 60. So we want 60 of these beautiful frames per second. Imagine how fast that is. It's like brrr, it's really fast, like a machine gun, just spitting out frames. And that's what's happening. Every frame, we're actually rendering the player and telling the window, okay, I'm done with this frame. But there's something we're missing here. I want to show you what's going on here, okay? So my player is being rendered. It's just one box. It's right here. But this is happening. So what is this, guys? What is happening here? Why is this a huge snake in my application or my game here? What is happening? It's like a painting program. And this is a good way to explain to you how a painting program might work. It doesn't really clear your image, does it? Because that wouldn't be a fun painting program. All you would see is just a circle. Whatever you render would be cleared the next frame. So usually you don't clear the frame in a drawing application like Paint. All right. In Paint, what happens is if I open up Paint here for you guys, if I render something for you here, a little box here, and I render another box, another box, another box, another box, it doesn't just erase everything. All right. But let me show you what happens if I erase something. So let me render a little box here. Okay. Erase that. Render another box for you over here. Erase that. Render another box for you over here. You'll see it looks like the box is moving. Just do that 60 times a second. That will be really fast. That's basically what's happening here. But to tell the computer to clear the previous frame is very important. So I want to clear it first, then render the new player object, and then tell it that the frame is done. And this is happening very fast. Update, render, update, render, update, render. So let me run this again. And let's see our player move without the previous position still there. Our position, current position of the player is being rendered. So we're moving around here, right? And this isn't really a game, obviously, but I could make it so that it'd be a game basically by clicking this, trying to click this. This thing is moving around randomly. You're trying to click it. Maybe that would be a game, considering that it's entertaining in some way. But this could be an application, might as well be an application. But a game engine, guys and girls, it does consist of these parts. All right, this is the most basic, absolute basic game engine you can make probably. It's very, very basic, but it shows you the steps that you require to make a game. And you can build on top of this if you want. This is the start of pretty much a lot of games that I make, or anyone else makes on this channel most probably. If you look at any of my game tutorials, you'll see me making a game just like this, starting off just like this, with an update and a render and all this kind of stuff. So just know that in your heart, when you're playing Assassin's Creed or Modern Warfare or Fortnite or whatever, you know that in the background, there's an update going on, fixing all the logic. You're pressing all these buttons real fast, editing, spamming, killing me with your dumb edits. Okay, if you're a Fortnite player, I'm sorry, probably better than me. Anyway, whatever you're doing on your keyboard, all this mouse movement, everything is update. It's updating, all kinds of math crunching going on. And that is then in turn being rendered directly after everything is done for that frame. It is rendered and visually represented using visual objects like squares, spheres, bullets. Everything is a visual representation to it. And it's a very basic sense. I'm sure Unreal Engine is a lot more complicated than this. Okay, guys, but in a basic sense, it's a loop with an exit condition and an update and a render call and a bunch of initialization functions. So there you go, guys and girls. Boom, my throat is done. I have spoken for a long time. Hopefully you understood. And if you have any more questions, let me know. Drop a like, subscribe as well. Check out the top right eye, check out the description box. Just drop a bunch of comments. Let me know what's going on with you guys. Hopefully you're doing good as well. There you go. Thank you so much. See you in the next one, right? Bye-bye.